Hello friends, this is a seminar of online math class. In this video, I'm going to solve 20 problems in differentiation. The essence of this is to help you to master differentiation appropriately. Okay, in the first question we have y is equal to x to the power of 3. If you want to differentiate any function, all you have to do, that is dy over dx, means any power you see, bring it at the back. So the power is 3. The 3 comes to the back. You write your x. The same power, take away 1. So this will give us dy over dx is the same thing as 3x to the power of 2, because 3 minus 1 is 2. In the second problem, you have y is equal to 3x to the power of 4. And if you want to differentiate this, again, the rate of change of y with respect to x, which is dy dx. So dy over dx is the same thing as 3 is already here. When the 4 comes back, it multiplies the 3. Then x, 4, take away 1. So dy over dx will be 3 times 4 is 12. And 4 minus 1 is 3. Okay, so let's take the third problem. 3 root x. So this is the same thing as y is equal to 3x to the power of half, if you know the laws of indices, because the square root of any number means that number raised to the power of half. So now dy dx will now be 3 is here, the half will come to the back. We'll have half x, half, take away 1 from the law. And 3 times half is 3 over 2 x to the power of minus half, because half minus 1 is minus half. This is still the same thing as 3 over 2 times 1 over x to the power of half, if you know the laws of indices very well, because the power to a negative power means 1 over everything. Then this is the same thing as 3 times 1. When you multiply 3 by 1, you shall have 3 over 2 x to the power of half. And you remember that from the laws of indices that any number to the power of half means square root of that number. So I can say that dy over dx is equal to 3 over 2 root x, and this is just the answer. So let's take the fourth question. Have y is equal to 2x to the power of 3 minus 5x squared plus 2. Then dy over dx is equal to 2 is here. The 3 will come to the back. X to the power of 3 minus 1 minus 5 is here. The 2 will come to the back. X to the power of 2 minus 1. Whenever you differentiate a constant, it's always 0. So that dy over dx is equal to 2 times 3 is 6x to the power of 3 minus 1 is 2 minus 5 times 2 is 10. X to the power of 1, no need of writing the 1, then 0 is nothing. So this is just the solution to this number 4 problem. Then number 5, we have that y is equal to 3x squared plus 1 over x. This is the same thing as saying that y is equal to 3x squared plus x to the power of minus 1 according to the laws of indices, because 1 over x is something as x to the power of minus 1. Then now take the derivative by saying dy over dx. Dy over dx is equal to 3 is here. The 2 will come to the back. X 2 minus 1 plus. Okay, let's remove the plus sign, because when the negative comes to the back, everything turns to negative x. You know I cannot write negative 1 because you don't say 1x. Supposing your name is Joy and I say 1 Joy, come here, you won't be happy because there's nothing like 1x or 1a. That is why you don't say 1a Buka, come here, 1 Joy, 1 Ifeanyi, and all that. So when minus 1 comes to the back, we just take it as negative. We know the coefficient is negative 1, but you don't write the 1. Then minus 1 minus 1. So that dy over dx implies 3 times 2 is 6x minus x to the power of minus 1 is minus 2. This is something as calling it 6x minus 1 over x squared from the laws of indices. So therefore dy over dx is equal to 6x, take away 1 all over x squared, and that's the solution to this number 5 problem. So let's go for number 6. So y is equal to x to the power of 3 plus 2x squared plus 1 all over x. Now, because of this denominator, you can divide everything by the denominator so that the differentiation becomes easier. So you can have that y is equal to x to the power of 3 over x plus 2x squared over x, then plus 1 over x. If you divide x to the power of 3 by x, you get x squared. If you divide 2x squared by x, you are getting 2x. Then this is still 1 over x can give you x to the power of negative 1. Then you can now begin the differentiation. So dy over dx will give us 2 comes to the back, x, 2 minus 1, plus, if I differentiate 2x, I will get just 2, plus, okay, rather, minus 1 comes to the back, will give us minus x, minus 1, minus 1. So that dy over dx becomes 2x plus 2 minus x to the power of minus 2. Minus 1 is minus 2. Therefore, finally, dy over dx will now give us 2x plus 2 minus 1 over x squared. That's the implication. X power of minus 2 is 1 over x squared. Okay, so let's take the seventh problem. Minus 3. So now this can be written as y is equal to x to the power of half. From the laws of indices, square root of any number implies that number to the power of half, plus this is something as 1 over x to the power of half as well because of the square root, then minus 3. So we shall have it as y is equal to x to the power of half plus x to the power of negative half, then minus 3. This and this are the something. Then dy dx, dy over dx will now be the half comes to the back, x half minus 1, plus, okay, rather minus because the power is negative is coming down, negative half x, negative half take away 1, then minus 0. Anytime you differentiate a constant, it will give you 0. So here dy over dx will give us half x to the power of negative half, because minus half minus 1 is minus half, minus half x to the minus half minus 1 give us minus 3 over 2. If you simplify this, finding the LCM, you must get minus 3 over 2. Do you know that the half is common? If I wish, I can factor out the half. Dy dx can be seen as half, which is common. Half is here, half is here. Then this x power of minus half can be seen as 1 over x to the power of half, minus this x to the power of minus 3 over 2 can be seen as 1 over x to the power of 3 over 2. This is the same thing as half into 1 over square root of x, because any number power of half means square root of that number, minus 1 over the square root of x, then to the power of 3. This is the solution to this particular question, that is the derivative. So dy over dx can be seen as half into 1 over root x minus 1 over root x to the power of 3, and that's the solution. Okay, so let's take number 8 question. It's just a function of a function, which might lead us into chain rule. The reason why it's a function of a function is that you can see a constant in the bracket and all of them are having an external power. So when such thing happens, you can say let u represent the terms in the bracket, and the terms in the bracket is 3x squared minus 2. That is what u shall represent. If this is u, it means that y is equal to u to the power of 3. Reason, all these things are now represented by u. So if you put u here, it becomes u power 3, which means y is now u to the power of 3. So find the y dx and find the u dx and the dy du. So du over dx means differentiating this. 3 is here, 2 coming to the back, you have 2x to the power of 2 minus 1. When we differentiate 2, you are getting 0. Hence, du over dx will give us 3 times 2 is 6x. That is what it will give you. Then look for dy du. dy over du will give you 3 will come, u to the power of 3 minus 1, which is 3u squared. This is dy over du. But from chain rule, we know that dy all over dx is equal to du over dx times dy over du. And what is du dx? Du dx is 6x multiplying dy du. Dy du is 3u squared. So dy over dx is giving us 6x times 3 will give us 18x u squared. But what is your u? U is equal to 3x squared. Therefore, dy dx will give you 18x into 3x squared minus 2 all squared, and this is your dy du. So let's take the ninth question. So in the ninth question, we'll have y is equal to the square root of 1 minus 2x cubed. Now, all you have to know is that this is something as 1 minus 2x to the power of 3 all to the power of half, because the square root of any number is equal to that number raised to the power of half from the laws of indices. Then the next thing to do now is to let you represent the content of the bracket. The bracket is 1 minus 2x to the power of 3. If this is so, it implies that y is equal to u power half, because this bracket is now serving as u. That is how you have u power half. Then find the derivative of du dx and dy du. So du dx is something as, if I differentiate, 1 is 0, 2 is already here. When 3 comes here, it becomes 3 minus 1 as usual. So that du over dx becomes minus 6x to the power of 2, because 2 times 3 is 6, is a negative value. 3 minus 1 is 2. Now let's go for dy du. For dy over du, you will have the half coming to the back, the same power, minus 1. That will give us half u to the power of minus half. Hence, dy over dx, dy over du will now give us half times 1 over u power half, because of the negative power here. So that dy over du will now be 1 over 2 root u, because any number power of half means square root of that number. But you should know that dy dx is equal to du dx times dy du. And what is du dx? Du dx is negative 6x squared, negative 6x squared times dy du. Dy du is 1 over 2 root u, 1 over 2 root u. So without wasting time, this can cancel out to have negative 3. So we are having it as minus 3x squared, minus 3x squared all over root u. Therefore, dy over dx will now be minus 3x squared over root. When you see u, you should know in the beginning that u is 1 minus 2x cubed. So we shall have 1 minus 2x cubed. And this is the derivative of this particular function. So let us take the number 10th question. So in the 10th question, we have y is equal to 1 all over square root of 1 plus x squared. This can be written as y is equal to 1 over 1 plus x squared to the power of half from the laws of indices. This is still the same thing as y is equal to 1 plus x squared all to the power of negative half, because of 1 over is a fraction. So this is what it will be from the laws of indices. Then you can let the content in the bracket to be u. So you say let u equals 1 plus x squared. So if this is so, it means that y is equal to u power negative half, because the bracket is now being represented by u. So therefore, y is equal to u to the power of negative half. So as usual, you take the u, the x, and the y du. So du dx will give us, if I differentiate 1, I get 0 plus, the 2 comes to the back, x, 2 minus 1 from here. So du dx will give us just 2x. Then you go for dy du. Dy over du will give us, the negative half comes to the back, You now have u power of minus half minus 1 from the rule. Hence, you shall have again that dy over dx is equal to minus half multiplying u to the power of minus 3 over 2, because minus half minus 1 is minus 3 over 2. This is still the same thing as minus half multiplying 1 over u to the power of 3 over 2. That's the implication when you take the laws of indices from here. Hence, dy over dx will now be, remember we are taking dy du, sorry. This is dy du. This is dy du, not dy over dx. So this is the same thing as minus 1 over 2 root u to the power of 3. That's the meaning, because this denominator of power of 2 here is something as half. So because when you have u to the power of 3 over 2 is something as saying u power of half, then bracket 3. And u power of half means square root of u, which we have written here. Then you write your power of 3. Remember there is a 2 here, so don't be confused when you see the simplification I've made here. So this is now serving as our dy du. Then remember that dy dx from chain rule, dy dx is equal to dy du times du dx. And dy du is this, negative 1 over 2 into root u to the power of 3 times du dx. Du dx is 2x. So you have your 2x. So 2 will cancel 2 without wasting time. We are having minus 1 times x is minus x all over root of u to the power of 3. But you should know again that u has a value in the beginning of this question. So dy dx will now be minus x all over the root of, seeing u, I will put 1 plus x squared, because u is 1 plus x squared, as you can see here, 1 plus x squared all to the power of 3. And this is the solution to this number 10 question. So let's go for number 11. Okay, in the number 11 question, if you look at it, you will see that this is a product rule. How do you know it's product rule? You can see carefully here that two things are multiplying each other. 3 plus 2x is multiplying 1 minus x. Hence, this is a product rule. And in product rule, you have to take this formula. The formula for product rule is telling us that dy dx is equal to v du dx plus u dv dx. So what you need here is to get your v, get du dx, get your u, get dv dx, and fix them in the formula. Once you fix it there, the answer comes right away. So you can say let the first term there be equal to v. So let v be equal to 3 plus 2x and the u be equal to 1 minus x. So I call the first one v and call the second one u. So we have got v and u. The remnant here is just du dx and dv dx. So dv over dx will give us, differentiating 3, I'll get 0. If I differentiate 2x, I'll get just 2. So dv dx is 2. So du dx will give us, if I differentiate 1, I'll get 0. If I differentiate minus x, I'll get minus 1. And 0 minus 1 is minus 1. So we fix them in this formula. Hence, dy dx, dy over dx will now be v. Our v is 3 plus 2x multiplying du dx. Du dx is negative 1 plus u again. U is 1 minus x multiplying dv dx. dv dx gave us 2. So dy over dx will now be minus 1 times 3 is minus 3. Minus 1 times 2x is minus 2x. Plus 2 times 1 is 2. 2 times minus x is minus 2x. Simplifying further here, you see that dy over dx will now be minus 3 plus 2 give us minus 1. And minus 2x minus 2x will give us minus 4x. And this is the solution to this number 11 problem. So let us take number 12. Okay, in question number 12, we have that y is equal to 1 minus 2x plus 3x squared into 4 minus 5x squared. This is still a product rule because you notice here that one bracket is multiplying another bracket. So you can say let v be equal to 1 minus 2x plus 3x squared, and the u become the second bracket, which is 4 minus 5x squared. If this is the case, you can say dv over dx, that is differentiating this dv dx, will give us, when I differentiate 1, I will get 0 minus. If I differentiate 2x, I'm getting 2 plus 3 is here. The 2 will come down, it will multiply by 2x, 2 minus 1. So that dv over dx will give us 0 is nothing, I will leave it, minus 2 plus 3 times 2 is 6x. That is our dv dx. Also, du dx, du over dx will give us, when I differentiate 4, I'll get 0. 5 is here, the 2 power will come down, it multiplies 5x, 2 minus 1. So that du over dx will give us 0 is nothing, I will leave it, minus 5 times 2 is minus 10x. This is the value of du dx. But remember that in product rule, that dy dx, dy over dx is equal to du over dx multiplied by dv over dx. Am I there? Du dx and dv dx, that is dy dx of but you know in product rule that dy dx is equal to v du dx plus u dv dx. This is the product rule. So from here we can continue. Our dy over dx will now be v. What is our v? Look at v here. V is 1 minus 2x plus 3x squared multiplying du dx. Du dx is minus 10x, so we have minus 10x plus our u is 4 minus 5x squared multiplying dv dx, and the dv dx gave us minus 2 plus 6x. Minus 2 plus 6x, you open the bracket, dy over dx will now be minus 10x times 1 is minus 10x, minus 10x times minus 2x is plus 20x squared, minus 10x times 3x squared will give us minus 30x to the power of 3 plus, open the bracket here, 4 times minus 2 is minus let's call it minus 8, because 4 times minus is minus 8. 4 times 6x is plus 24x. Minus 5x squared times minus 2 will give us plus 10x squared. And minus 5x squared times 6x will give us minus 30x to the power of 3. So you collect like terms, you will now see that dy over dx will now be to the power of 3, we have minus 30x and minus 30x cubed. If you add them together, you get minus 60x to the power of 3. You look for power of 2, we have 20x squared and the 10x squared. If you add together, you get 30x to the power of 2. Then look for ordinary x, minus 10x plus 24x is plus 14x, and we have only one constant here, which is minus 8. So this is the derivative of this given function. So let's take the 13th question. This quotient rule. Quotient is the result you get after division. So whenever you see something that looks like one is dividing the other or a fraction, you know that you are using quotient rule. And quotient rule is telling us that dy over dx is equal to v du dx minus u dv dx all over v squared. V is usually the denominator while u is the numerator. So you can say that v is equal to 1 plus x squared, the 1 minus x squared, because v is the numerator, the denominator, while u is the numerator, which is 1 plus x squared. So you take dv over dx, differentiating this. When I differentiate 1 is 0. If I differentiate minus x squared, I will get minus 2x, because the power of 2 will come to the back. then du over dx will give us, if I differentiate 1 is 0, if I differentiate x squared, that will give me 2x. So you can now apply the formula. Dy over dx implies v, our v is 1 minus x squared, multiplying du dx. Du dx is 2x, you compare it, minus our u is 1 plus x squared, 1 plus x squared, multiplying dv dx. Our dv dx is minus 2x, so you have into minus 2x all over v squared. Remember, our v is 1 minus x squared, so you have 1 minus x squared all squared. So continuing from here, you will see that dy over dx will be equal to, I'll use this to open the bracket, 2x times 1 is 2x. Take away 2x times minus x squared will give us minus 2x to the power of 3, minus negative 2x times 1 will give us negative 2x, and negative 2x times x squared will give us minus 2x to the power of 3, all over 1 minus x squared all squared. So dy over dx is equal to 2x minus 2x cubed, minus minus turns to plus, plus 2x, minus minus turns to plus, plus 2x to the power of 3 all over 1 minus x squared, then to the power of 2. So you now see that dy over dx will now be 2x plus 2x is just 4x, minus 2x cubed plus 2x cubed has gone, leaving us behind with 1 minus x squared all to the power of 2, and this is the derivative of this number 13 question. So let's take number 14 problem. So number 14 question is an implicit differentiation. It is implicit in the sense that x and y are not staying alone. You see, they are all mixed up, unlike explicit differentiation whereby y is always alone and x is always alone. So when you encounter something like this, you always attach dy dx whenever you differentiate with respect to y alone. Okay, but this time around we are seeing the product rule because x squared is multiplying y, and here y squared is multiplying x, so it's a product rule. So you let the first one be v and the second one be u. Remember product rule, dy dx is just v du plus u dv all over dx. This is product rule. Then you can say our v is already x squared and our u is y. So dv dx will give us 2x when I differentiate this. Then du dy will give us 1. If I differentiate y, I'm getting 1, but that one will be, I must attach dy dx, because anytime you differentiate with respect to y, you must attach dy dx. So I'll fix it in this formula. I will now have that dy over dx will now be v. Our v is x squared multiplied by du. Du is dy dx, so you have dy dx plus the next thing there is u. Our u is y multiplied by dv dx. Our dv dx is 2x. Okay, plus coming here, this is still product rule, so we do the same thing, but this time around we shall let our v be equal to y squared and our u be equal to x. So from here, dv over dy here will give us 2y, but I must attach dy over dx because I am differentiating with respect to y. Then here du dx, du over dx will give us just 1, because if I differentiate x, I will get 1. So putting in the formula for product rule, I have v. My v is y squared multiplying du dx. Du, where is my du? Du is 1 plus u. What is u? U is x multiplying dv dx. dv is 2y dy over dx then plus, if I differentiate 4x will give me just a 4 equal to, when I differentiate 1, I'm getting a 0. So arranging this thing properly, this will now be, this is not necessary. This will now be x squared dy over dx plus y times 2x is 2xy plus y squared times 1 is y squared plus x times 2y dy dx will give us 2xy dy over dx equal to -4. I'm bringing this -4 to this side. Okay, so from here you will see that dy dx is double. I can pair them, so I have x squared dy over dx plus 2xy dy over dx equals -4 is already here. I can bring in -2xy as well as -y squared to the right hand side. Then at the end of the day, we see that dy dx is common here. You can factor it out, so you shall have dy over dx into x squared plus 2xy, that is what you're having here, equals -4 minus 2xy minus y squared. So to get dy dx, divide both sides by the coefficient, which is x squared plus 2xy over x squared plus 2xy. By so doing, you find out that dy over dx will give us -4 minus 2xy minus y squared all over x squared plus 2xy. And this is the solution to this implicit differentiation. So let's take question number 15. Okay, in question number 15, we still have implicit differentiation because x and y are not staying alone. Remember, anytime you differentiate with respect to y, you must attach dy dx. Ordinarily, if I differentiate x squared, I will get 2x plus. If I differentiate y squared, I will get 2y, but I must attach dy over dx equals, any constant I differentiate is 0. Therefore, 2y dy over dx becomes, when positive 2x crosses over here, it becomes -2x. So to get the value of dy dx, I will divide both sides by 2y. I will divide both sides by 2y. 2y will cancel 2y. I will now have dy over dx is equal to, from here 2 we cancel out, we have -x all over y. So this is the derivative of this particular function here. Okay, in the number 16 questions, we have x squared plus 2xy plus y squared equal to 5. This is yet an implicit differentiation because x and y are written together. So if you differentiate x squared, you must have 2x plus, this is product rule because 2x is multiplying y. So I can say let u be equal to 2x and v be equal to y. And product rule is v du plus u dv. So let's get du. Du here will give us 2. If I differentiate 2x, I'll get 2. So that dv will give me just 1 dy dx, because anytime you differentiate y, you attach dy dx, and 1 is the same thing as removing it. So from here you have v. Our v is y multiplying du. Du is 2 plus u. Our u is 2x multiplying dv, and dv means dy over dx. Then plus, if I differentiate y squared, I will get 2y. I must still attach dy dx because I'm differentiating with respect to y. When I differentiate a constant, I will have 0. Okay, so this is something as writing 2x plus 2y plus 2x dy over dx plus 2y dy over dx equal to 0. Now dy dx is common here. I can factor it out, but before that I have to bring in these values here without dy dx to the right hand side. So from here I have dy dx being factored out, so I'm left with 2x plus 2y here. 2x plus 2y equals 2x coming here becomes -2x, 2y coming here becomes -2y. So to get dy dx, I will divide both sides by 2x plus 2y. 2x plus 2y over 2x plus 2y. This will cancel out. You now see that dy over dx becomes, negative is common here, so you can have negative 2 into x plus y over, coming here 2 is still common, you have 2 into x plus y. X plus y will cancel, x plus y minus 2 divided by 2, you will see that it's gonna give you -1. So the derivative of this function is just -1. So let's take the next question. Okay, in the number 17 question, we'll have trigonometric differentiation, where you have y is equal to cos 2x. Now, to differentiate this, you can say let u be equal to 2x, whatever you are having here, let it be equal to u. If that is so, it means that y is equal to cos u, because 2x has been represented with u. So take du dx. Du dx will give us 2, because when I differentiate 2x, I'm getting 2. Also, dy over du, if you differentiate cosine, you are getting negative sine u. Remember, there is the basic derivative. If d dx of sine theta, d dx of cos theta, and d dx of tan theta, these are the basic you need to know. This will give us cos theta, this will give us minus sine theta, and this will give us sec squared theta. This is the basic, you should know this. Anytime you differentiate this, this is what it will give you. That is why cos u turns to negative sine u. But this is a chain rule, and chain rule is telling us that dy over dx is equal to dy over du multiplied by du over dx. Therefore, dy over dx will now be, dy du is negative sine u multiplying du dx, which is 2. If you multiply out, you see that dy dx is the same thing as -2 sine u. But you know ab initio that our u is equivalent to 2x, so you can remove this u that is here and plug in 2x. So the answer is -2 sine 2x. That's the derivative of this particular function. So let us do this one here. Okay, so for number 18, you can as well say let u be equal to 1 over 3x. Therefore, y means sine u, because 1 over 3 has been represented with u. So you take du dx. Du over dx will give us, if I differentiate this, I will just get 1 over 3. Then dy over du will give me cos u. Whenever you differentiate, sine is cos. Then from chain rule, dy dx is equal to dy du times du over dx. Therefore, dy over dx will now be dy du is cos u times du dx, which is 1 over 3. If you take the product, you shall have 1 over 3 cos u. Therefore, dy dx will now be 1 over 3 cos, seeing u, you put 1 over 3x, 1 over 3x, and that is the derivative of number 18. So let's go for number 19 and number 20. Okay, in question number 19, we have that y is equal to tan 5x. So you can say let u be equal to 5x, which implies that y is equal to tan u, because u has been represented with 5x. So you take du dx. Du dx will now be 5 when I differentiate this. Also, dy du will give us, if I differentiate tan u, I will get sec squared u from the basic derivative. From chain rule, dy dx is equal to dy du multiplied by du dx, and that will be dy du is sec squared u multiplied by du dx, which is 5. By that multiplication, we are getting 5 sec squared u. So therefore, dy over dx shall be 5 sec squared, seeing u is 5x, 5 sec squared 5x. And this is the solution to this number 19. So let's just take the last question of the day. So in our last question, which completes 20 derivatives, we have y equal to cos squared x, no more y equal to cos 2x. They are different things. Do you know that this can be written as y is equal to cos x all squared? If that is the case, it implies that we can say let u represent the content of the bracket. So let u be equal to cos x. It now means that y is equal to, seeing cos x, I'll put u, then all squared. So you take du over dx. If I differentiate cos x, it will give me minus sine x. Then dy du, dy over du. If I differentiate u squared, it will give me 2u. But dy over dx is equal to dy over du times du over dx. Therefore, dy dx will now be dy du is 2u multiplying negative sine x. So if we take this product, we shall have that dy over dx is equal to minus 2u sine x. But what is our u? Our u is cos x. Therefore, dy over dx is equal to negative 2 cos x, because u is cos x, then sine x. And this is the derivative of this particular function. So we've successfully dealt with 20 derivatives. Thank you for viewing, and may God bless you.